Hi, welcome back to News in Chemistry. This is Empirical Molecular Formula lesson number 3. Okay, an empirical formula are the simplest form of formulas using the simplest whole number ratios. A molecular formula shows the number of atoms within a molecule that are not often in the simplest whole number ratios. That's the difference between the two. And remember that 1% is equal to 1 gram. Okay, let's look at our first problem here. A sample gas which contains carbon and hydrogen has been compressed and liquefied. It was found that the mass was 4 grams, which contained 3.6 grams of carbon and 0.4 grams of hydrogen. What is its empirical formula? Okay, so what we're going to do is we're going to take 3.6 grams of carbon and we're turning into moles of carbon. So remember, it's a molar ratio. Now, where that 12.1 grams come from? It came from the periodic table. So it's going to give you 0.2997 moles of carbon. The next one is going to be 0.4 grams of hydrogen times 1 mole of hydrogen divided by 1.01 grams of hydrogen. I'm not using diatomic hydrogen here. And when we do that, we came up with the number 0. Looks like 3960. Okay, dokie. And that's mole of hydrogen. Now we want to set up and see what the empirical form is going to be. So we take carbon, and it's the smaller of the two numbers, so we're going to put it over itself. And hydrogen, so we give me a 1 to 1.32. So we need to make that 1.32 as close as possible to a whole number ratio. So we would have to multiply this by 3 and this by 3. And this would give me 1. No, it would give me 1 times 3 is 3. And this would give me 4. So that would make the formula C3H4. Pretty snarly, huh? Let's look at the next problem. What is the empirical formula of a substance that is made up of 66% carbon, 5% hydrogen, and 29% oxygen? Okay, this one's pretty easy itself. Okay, so when we look at this, let's see what we've got here. Okay, we've got, yes. So we go 66% would be the same as 66 grams of carbon, right? Because 1% equals 1 gram, right? Times 1 mole of carbon divided by 12.01 grams of carbon. And we're going to get our calculator here, and that's going to give me the value. Let's see here. 66 divided by 12.01 would be 5.50 roughly, or 5 point. Let's go with 5.49 moles of carbon. You could call it 5.50. It's not gonna matter much. The other one is going to be, so you take 5 grams of hydrogen times 1 mole of hydrogen divided by 1.01 grams of hydrogen, and that is going to equal, let's see here, 5 divided by 1.01, 4.95. Right. Mole of hydrogen. And last but not least, we have the 29 grams of oxygen times 1 mole of oxygen divided by 16 grams of oxygen. We're not using diatomic oxygen. And this gives me 1.18. 1.8, sorry, 81. Got it. All right, now, this is mole of oxygen. All right, so what we're going to do is we're going to take the smallest one, which is oxygen, and put it over the other guys. So we'll do carbon, hydrogen, and oxygen. So we're going to get 5.49 divided by 1.81, 4.95 divided by 1.81, and of course 1.81 divided by 1.81. All right, so you know that this value is going to be 1. What about the hydrogen? It's going to give me 2.7. And the carbon? And that's going to give me 3. Okay, so with that in mind, now what we have to determine is our empirical formula. But when we look at that, we notice that we have that 2.7 there. So what we're going to do is we're going to go ahead. 2.7, if you doubled it, it'd give you like 5.4, and you double it again, that gives you 10. So that gets really high. So 2.7 is going to be close enough to 3, I think. So we're going to say it's approximately 3. So now the empirical form is going to be C3H3O. And that's it. You guys be snarly, and we'll see you back here at Moosing Chemistry.